A stream cipher is a kind of practical one-time pad. Instead of sharing beforehand a key of the length of the message, both sides of the communication use a pseudo-random generator to produce the same continuous key stream, which is used to encrypt and decrypt messages. Once the key stream is generated, stream ciphers work like one-time pad. Encrypting and decrypting consists of an XOR operation. There are several stream ciphers. The way they generate the key stream differentiates them from each other. A stream cipher is a symmetric key cipher where plain text digits are combined XOR with a key stream. The pseudo-random generator produces digits on demand to feed the key stream. Each plain text digit is encrypted one at a time with the corresponding digit of the key stream to give a digit of the ciphertext. So since I'm talking about pseudo-random generator, let me open a short parenthesis on randomness. A pseudo-random output is the output of a mathematical function. The output looks random. When I say looks random, I simply mean that it is unpredictable from output to output. But each output is the result of a mathematical function, so it's not truly random since the function is deterministic. For your information, a truly random output can only be obtained by measuring some physical phenomenon, like the atmospheric noise, for example. So what should we use to produce our key stream? A pseudo-random generator or a truly random generator? From the security point of view, a truly random generator would be better. But as we are going to see, by using a pseudo-random generator, we can get the communicating parties to generate the same key stream independently. With a truly random generator, we could not do that, and we would be faced with the problem of sharing the key stream as with the one-time pad. If you want to read more on randomness, I advise you to follow the link on the slide. The key stream is generated by a pseudo-random generator that takes as input an initial seed and returns an unpredictable key stream. Formally, a pseudo-random generator is a function from a seed space to a key stream space where the length of the seed is much smaller than the length of the key stream. Typically, the length of a seed ranges from 64 to 512 bits. This seed is in fact the shared secret between the two parties. Stream ciphers work like the one-time pad, where the one-time pad key is replaced by the generated key stream. The seed K is the secret key, shared between the two parties to generate the same key stream. So Bob feeds the pseudo-random generator with the shared secret seed K to produce a key stream J of K. The key stream is XORed with the plain text M. Bob sends the encrypted message C to Alice. And Alice uses the shared secret seed K to produce the same key stream and XOR it with the ciphertext C to obtain the plain text M. The seed must serve only once. If you reuse the seed, then you will produce twice the same key stream, and you will get an insecure two-time pad. So the question that comes to mind is how can both sides share the same seed for each message? The general idea is that communicating parties share a fixed secret key, for example a Wi-Fi network key, and use a common method to derive the seed for each message from this key. I will not describe this common method. However, consecutive seeds must not relate to each other. Related seeds was one of the flaws of the wireless encryption protocol that allowed it to be broken so easily. one of the flaws, because this protocol had many other flaws. There are several stream ciphers. What makes them different from each other is the way they generate the key stream, since encrypting and decrypting is a simple XOR operation. A commonly used stream cipher is SALSA20 or its derivative SHA-SHA-20. Stream ciphers are fast. They are used for encrypting, voice over IP and Wi-Fi communications, but not only. SHA-SHA-20 can also be used for encrypting communications between browser and web server in the framework of the SSL-TLS cryptographic protocols. In this video, I briefly presented stream ciphers. I didn't go into detail. In particular, I didn't show how to build a pseudo-random generator. I considered pseudo-random generator as black box that produces unpredictable outputs. One of the main advantages of stream ciphers is that encryption and decryption is fast. It is a simple XOR operation. Contrary to one-time pad, stream ciphers are not perfectly secure, since they use a pseudo-random generator to produce the key stream. However, there is no known attack on a stream cipher like SHA-SHA-20.